Leiter und das automatisch landen.
Ja, sowas wie die Flachkuhle oder sowas.
Ach, schade. Ach, du hast ja gefilmt, Martin.
Not only in the air, also on water, we did a big step forward with our magic Boxwing project. So let's take a look what we've done. I think this little, but you see here, this works. It starts gliding. At first, the Boxwing project should be just a nice looking and nice designed Boxwing, like its name says. But then we want to push our limits. And so the Boxwing should start vertically, land nearly vertically, and also should be able to start and land from water. Let's see how we accomplish this. Here you can see how we are modifying the flat surface from the middle fuselage to a kind of boat, that we got much more lift when it is on the water. The difficulty while designing this boat fuselage was that it is nearly optimized for flight and also for gliding onto the water. It shouldn't produce too much drag in the air and also should have this necessary step to glide off the water surface. It should also be possible to start this Boxwing from a grass surface, so the lower bottom of this middle fuselage is optimized for water and grass, and this makes it a little bit difficult to maintain all these different start options. The first benefit of this deeper bolt hull was that we got a lot of more space to install all the RC and electronics. You can see here the battery still nearly touches the canopy, but at the end everything fits in perfectly and also will be super easy to reach and maintain. Here we are optimizing the vertical start position and make this end tops of the fuselage a little bit longer to give more clearance for the inner elevators. Also the outer pontons has to be optimized for the water start. They got also this little step and some nice curves like a boat. On this first water version of the fuselage we had been a little bit too optimistic. It sank too deep into the water and produces too much drag, especially on the outside, so it was not possible to direct it on yaw. So we had to start again with a much, let's say, bigger and more volume fuselage. No control on yaw. But at the end, this second prototype was the first one who performed a vertical takeoff. It works! It works! It flies! Here you can see the differences between the first and second version of the boat fuselage from the Boxwing. It got much more volume to swim higher on the water, to get much more clearance, especially to the outer pontons for better yaw steering. As next step, the motors has been moved much more forward to get them out of this turbulent air which is produced by vortices when the delta wing has a high angle of attack, which you can hear when I start a Boxwing. On the next Boxwing will also be much more stronger engines installed, so we had to reinforce the vertical stubs and also the motor mounts. And last but not least, to optimize the airflow on the outer wings, we installed some sleds to prevent this wing from immediately stalling. We want a smooth transition from normal flight to this nearly vertical landing. And these sleds will help that the airflow won't get off too suddenly. Additional to the sleds, some wing fences has been installed. This was mainly done to separate the airflow from the propeller, which is just over the inner wing, or better said, it should just stream over the inner wing, so the airflow from the inner and outer wing should be separated, that we got a maximum lift on the outer wing and less stall tendency. Today's video is sponsored by PCBWay, which offers you great prototyping services like CNC machining, sheet metal forming and 3D printing. They offer a big variety of many different materials. You can easily drag and drop your projects on their website and they will manufacture it for you and send it within 24 hours if needed. They got great machines and great services, so check out their website pcbway.com. So let's get the next prototype printed. For the final Boxwing, we got the canopy and fuselage, big bolt fuselage. Let's see how deep it is. And the Bamboo Lab already finished 2 wing parts. Always amazed from the quality. And the Ender is building the upsized vertical steps. Here we got the outer wing with our Aero JTP on it. And what we got to here are canopy. The rear canopy this time in yellow and outer wing parts all here on the Ender and the CR10. Rudder as well. Aft fuselage parts nearly finished, and the K1C also making a big fuselage part. Parts are already printed. Let's build this thing new and much better. This should have a good buoyancy on the water. Yeah, the slits for the fins. It's so cool. Here we have a comparison to the other one. You see it's much higher. Canopy is getting ready. Canopy is 31 grams, 118 grams. Time for the wings. Bringing wings and fuselage together. The new side fins just getting ready for underwater stabilization, also on land. And some servo plates. Here the fins are installed on the ground, on the bottom of the Boxwing. And this is the reason why, when it starts on land, on grass, it shouldn't tilt completely to one side so that these outer pontons stay in the air. This is important for maneuvering on land. Now the wing got its new vertical steps. They are much bigger and much more solid for stronger engines. And also the upper wing completely new designed with longer nacelles to bring the engines more forward. And we got these nice tiny sleds. They look so wonderful. These are printed from PLA. The rest is lightweight PLA as well. And also these fences to separate the airstream on the outer wing and the propeller stream, that this area stays clean from the propeller stream. I think this should work really nice. And let's assemble. Weight from the whole upper wing is 75, let's say 75 grams. First assembly of the Boxwing water version. Final design. Looks absolutely amazing. Just love these upper wing details with the fences and also the sleds. Let's see how they work. Will be super interesting. Also the small fins. I think also in the air this will look beautiful. Our flying Boxwing boat. Let's go on with the resin. Electronic is installed. Last check. Elevator, rudder is working, and engines. Okay, both rotate to the inside like it should be. They run super smooth. I'm using here the F60 T-motors. Let's see how much thrust they bring. Flying weight is 791 grams, so nearly 800. This is about 100 grams more than the last version. I think this is caused by this bulky fuselage and these extra fins and also the other extra stuff and stronger and heavier motors. But let's see how much thrust we get. So we got again these 5-inch 3-blade props and on 4S. And let's see, everything on 0. And I will go for 1 inch more. This is 6 inch, the maximum possible size. I think here we got about 6 or 7 millimeter. Oh, even less. Oh yeah. That's quite close. That's really close. So 50 amps and over 2 kilograms. See the temperature. Yeah, temperature is okay. Getting warm. I think that's quite perfect. We got a little bit more noise. I think this is because they come quite close to each other. But we got maximum static thrust. That's what we need. Let's go to the water. Oh, there's something wrong with the rudder. The Boxwing still is diving too deep in the water. These outer pontons should stay about this way, so we need 2 more centimeter lift. I think the whole fuselage should be more wide underneath. It's still a lot of things to do. Even when there is big progress, it's still not perfect. Here I painted the actual water level and the water level we need. This is here, I can put this up. It's about 8 millimeter higher. And this level would be exactly this, that the outer end of the pontons is out of the water, that they really just touch the water. This is the minimum lift we need. 1 centimeter would be even better. We will go for 1 centimeter, and the idea is dynamic lift bodies into the water, that we got much more lift. So these first small fins were not that big success. Maybe they also got the wrong angle and produced some downforce that brings the whole plane underwater. They look good, but we need some much more bigger ones that should do 2 favors on our side. They should produce static lift and also hydrodynamic lift, and maybe also aerodynamic lift. After we finished this issue with the rudder, which stuck from time to time, which needs some more space to travel, we designed some nice propeller with the actual 3-blade design, and afterwards we started with the new underwater fins, and we begin with a very clean block, just a kind of cuboid. At first we managed the correct position this time. It should stay underwater and also got a positive angle of attack that it produces immediately uplift when the Boxwing starts traveling into the water. These big fins or floats has again 2 jobs. They have to stabilize the Boxwing on water surface and also on the grass surface. Also the canopy was tuned with a small lip to tighten it up against water. Here we are simulating the buoyancy of the Boxwing. Maybe this was again a bit too positive. So these new fin parts are just getting ready. Last prints, here they are ready. Let's install. The camera holders are ready. Bamboo Lab did again a great job. Let's see how they fit. Super lightweight, made from lightweight PLA of course. 2 volts. First I'm removing these old fins with the oscillating saw. This works really good on lightweight PLA, and a bit sanding afterwards with the rotary grinder. Here they are, these new side floats, and they will go like this. Looking wonderful. And here they are, first installation. Now I'm filling this gap with a bit super glue to tighten it up against water, and then they will be covered with resin, and it's done. Take a look on the ground position. They shouldn't be too much forced when it lies on the wingtips, so there is always a small gap, and when it's rolling up, angle of attack, so when it is floated, something like this, you see this lower underwater wings should immediately produce lift, that it comes out of the water very fast. It should be a STL water plane, for STL for in the air we got all these aerodynamic tuning, and for underwater or for water start we got this water tuning. So it's really a hybrid plane with a lot of specialties. And the next try. The time. Yeah, it's better. and I can steer it better. But I'm starting having control. But not enough for the small leg. I need even more your authority. But it's much better than before. See here? I think this little, wait. But you see here, this works. It starts gliding. Yes, this works great. This works. And it has a nice angle of attack, so if I would give full throttle, I think it would start. Yeah. This thing will start. This will start. Even when this new fuselage with these big fins worked nice on water, on grass it shows off a big instability on yaw. This crash just came out of nowhere, and it took me 2 more crashes till I realized it was caused by these 2 big props which run too tight together. If one of you has a physical explanation for this phenomenon which causes a big roll force where it was not possible to steer against with aileron, please write it in the comments. Luckily all these damages could be fixed again with super glue, and I also got the smaller props, the 5-inch ones, with me, and after installing them everything runs as usual without any problems.
Krass. Das waren die Propeller.
Wenn er fliegt, fliegt er.
On this day I was super euphoric, and I also planned the first water starts, but after these 3 crashes on the ground and trouble with the propellers, I just had some time to do some first adjustments with this new prototype, and it was also getting dark, so let's go on the next day.
Es ist eine kleine Zicke. Es ist eine Zicke. Es hat phänomenale Eigenschaften, ja, aber
Ich glaube, ich lebe auch nochmal Zackenband auf. To reach the same thrust on smaller props, I changed the 3 blades one to 6 blades, so they bring also about 2 kilograms, which will be enormous in the next start. The controllability was already much better than with the pre-runner. Also you can hear the sound when the propeller suck in these vortices from the delta wing. Is not that loud. This Delta Boxwing is not a normal airplane with not normal flight characteristics, so it needs time to understand it and some flight training, but it is so much fun and you can do so different things with it than with other airplanes that I really enjoyed every second flying the Boxwing. These training flights are also necessary for the first water landing, because there is no room for any mistake. Control while these hover maneuvers is given through the propeller stream, which runs over the inner elevators, which works as ailerons, and the rudders as well, and this works really easy. You have full control on all 3 axes. There is a gyro installed, but the gain is really low, and I put it to nearly 0, and this was still controllable, but to be honest, it is much more easy and much more comfortable when there is a gyro on board, even when it's getting very windy. And at the end, it is training. It needs some flights, starts and landings to do these special maneuvers, but it's getting better and better, and this is just my, I think, 1 hour flight time together I have with this thing, and I did my first very short landing.
Einwandfrei.
Ich glaube, ich mache die Gaskurve wieder ein bisschen flacher. Ich hatte die zu steil, weil die haben echt Power, die Dinger, ne? And after all these test flights, it was time to do some near-ground acrobatics with the JRM1 Junior.
Ah, das sieht geil aus.
Schöner Himmel heute. Ja, du musst natürlich mit Seite das machen. Mit Querversuchen. Ja, das geht nicht. Ich muss mal landen, René.
Ja.
Flying the JRM Junior in high alpha is much more easy than doing the same with the Boxwing, and the reason is that the thrust is in the same level like the horizontal CG, and you see that the engines on the Boxwing are up leveled, so they are much above the horizontal CG, so every high alpha must be pulled with a lot of elevator. And so I think I will use them some stronger servos, also some.
Sehr schön.
Ich bin.
Bist du happy?
Ich bin. Zieh meinen Hut, ne?
Zieh meinen Hut.
Professional Turbine Flyer approved.
Yeah.
Nehme ich so.
Normally he flies this one.
Some more fast ones. This should make this high alpha flying even much more easy. And if this is not enough, we have to level up the battery, but this would be only the very last choice, because we are super happy with the design and the battery is already inside on top of the canopy, so the whole design would have changed. But I'm looking forward that all goals we set we will reach with our Boxwing.
Geil. Tipptopp.
Wir fangen!
Sehr schön.
Sehr schön.
And maybe next time Tommy catches the Boxwing. Thank you very much for watching the video, and hopefully the next one we can see some cool water starts and landings.